Hello everyone, welcome to BYJU'S exam prep. I hope everybody is doing very well, guys. And tell me who has joined the session. Let's everyone join the session because today's session is going to be a very interesting and informative session. And for the gate point of view, this session is going to bring you so much knowledge for the topic of transient. And we will do the transient in a very easier way and very complex way. In very easier way and very compact way, so that you will learn all the concept in a less amount of time and then practice more and more questions. Okay? So जल्दी से बताओ किस किसने सेशन ज्वाइन कर लिया. Tell me who has joined the session. Let me share the session also. And बच्चों आप लोग भी सेशन को शेयर करो. मैं भी जस्ट सेशन को शेयर कर रहा हूँ. ठीक है, जितने भी आपके स्टडी ग्रुप्स है एंड जितने भी आप लोगों के दूसरे ग्रुप्स है, आप उनमें भी इस पर्टिकुलर सेशन को शेयर कर सकते हो, because this session is going to help you a lot in your this particular topic of transient. So good afternoon Rohit. Good afternoon Rohit. How are you? तो बच्चों जैसे कि आपको पता ही है that in the last week and the yesterday's class we have completed the topic of two-port network, right? We have done the two-port network and we have seen so many questions of two-port network with all the concept that is available for our course. Now starting from today, for the next 3 classes, we are going to learn about the very important concept, which is a transient analysis. You can expect directly 3 marks question from this topic. One is 2 mark question and one is 1 mark question. And let me tell you, the questions are very much easier if you understand the topic well. Okay. So let me introduce myself. Wait a sec. My name is Shan Mudgal. I have I have a 6+ year of teaching experience. I'm a gold medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. And right now we are doing the network theory. Before starting a session, let me give you one small information that Abhinav sir is going to bring a workshop on 11th October on the topic of is it possible to cover GATE 2024 syllabus on a time in a timely manner at 7:30 p.m. And guys, this session is going to be very important for you, because from this session you will get to understand how to revise the syllabus also, because you know less than 4 months are left, so you need to revise syllabus on a timely basis also. Apart from that, bachcho, we have bring a national scholarship test like every year for a GATE examination. In this test you can get the scholarship up to 90% for our programs. This scholarship test is held on 15th October between 9 a.m. to 9 p.m. So you can register for it and you can start your preparation for the 2024 GATE exam. Good afternoon, Sheikh. Okay. So today we are going to understand a very important topic of transient analysis. And before starting a topic, kindly share the session among your friends so that more and more students can come. So what do you mean by transient? A basic question. Ki transient hota kya hai? What do you mean by transient here? See. Transient nothing is just a sudden change that comes in your network, and because of that the network behave differently as compared to the particularly your steady state network. आज का टॉपिक डिटेल से बोलिए प्लीज. हाँ शेख, हम नेक्स्ट 4 क्लासेस जो ट्रांसिएंट की है उसमें हम लोग डिटेल में ही बात करने वाले हैं. Venkatrans, before attaining a steady state. Okay, good. Before attaining a steady state. Okay. So simple transient definition, everybody knows. Everybody knows that it is a state or that can occur because of the sudden change that comes in a network. Now, what do you mean by sudden change? This change can be switching. For example, if we'll switch on and off. This sudden change can be the short circuit. As you know, because of the short circuit, the fire occurs. The sudden change can be anything. But the important point for any network to go into a transient, you need to understand. For any network to go into a transient, they should satisfy 2 points. First, there should be a sudden change. And second, there should be a storage element, energy storage element. There must be an energy storage element present in a circuit. Now, energy storage element are inductor and capacitor. So if these 2 conditions are satisfying, then your network will definitely going to go into a transient state. Okay, if you are supplying a DC. If you are supplying the AC, then there will be a condition that your circuit may or may not go into a transient state. Now, transient state comes before a steady state, as told by a Venkat. But understand what is a steady state first. A steady state is a state where equilibrium of energy take place. Okay, but a transient state occur before that, and also it can occur after that. This point you need to understand that once your network is in steady state, if you provide a disturbance in a network, it can go into a transient state, and once a disturbance dies, then you again come into a steady state. So if in your interview exam you will say that transient state comes before steady state, then they may give you a 0 mark. Okay, so transient state is a state that will come because of sudden disturbance. This definition you should provide in your interview or before if you're teaching someone else. Okay, so now for how much time the transient state occur? Transient state occur approximately from microseconds to milliseconds, because in transient state, high amount of energy transfer from one point to another point. If the time will be large, it will be damage your whole network. Now, microsecond transient state you will generally see in a power system, and in millisecond transient state we will see generally in our subject network theory. So Venkat is saying, yes sir, because of sudden change in input. Not in input, again, not in input in the circuit. It can be input, it can be circuit, because for example, in a circuit, you are doing the switch on and switch off. That is the changing in a circuit. For an input, for example, you are applying a step input ekdam se, then again it will be a transient state. Okay, so for a system we will say. Now bacho, in a transient state you need to understand 2 points. What is the time constant? What is the time constant? What is the time constant? Can anybody tell me what is the time constant? Definition, not formula. I know you know the formula well, but what is the definition of time constant? Simple, huh? The time constant definition depends on 2 particular perspectives, that whether your network is in charging or discharging mode. Whether your network is in charging or discharging mode. On that basis, we will have a time constant formula. Now, what is the meaning of charging and discharging mode? It depends on the energy storage element. If the energy is storing in a circuit, it means it is in charging mode. If the particular energy storage element is giving out the energy, then it will be in a discharging mode. Okay. So in a charging mode, time constant means time taken by circuit to charge up to 63% of final value. To charge up to 63% of final value. Okay. Now, in books, you will see the 63.2 also. Okay. That's not worry. I'm taking a round off number. So that time at which your particular circuit charged to 63% is known as a time constant. Okay. 1 by E times. Yes, correct. 1 by E times is actually 63%. Correct. That time the transient occur and stays in a circuit. Nahi beta, this statement is incomplete. If you say that time in transient occur, that is actually the transient time. Transient time, if I talk about the transient time, it is TS. It will be greater than the time constant. Remember, the circuit will remain in a transient state more than a time constant. Okay, so this statement is not correct. Now for discharging circuit, time taken by circuit to discharge up to 37% of initial value. 37% of initial value. 37% of initial value. Now understand, again, in some books, you will find out 36.8. That is also correct. I'm taking a round off number. So 37% of initial value. Okay. Now let's talk about the transient time. Transient time is actually given by the settling time. It is actually equal to 4 times of tau. Generally, I will say generally it is equal to 4 times of tau. We have another value of settling time like 3 times of tau, 5 times of tau, but that is a part of your control system. So I'm not discussing that point here. Any doubt till here? We have discussed what is a time constant. That is important before going into a concept first, right? Now, charging and discharging is going to happen. Now, first of all, to understand further, you should understand what is the order of a circuit. What is the order of a circuit? Let me take one blank page. Wait a sec. Let me take one blank page. Okay. Now, what do you mean by the order of a circuit? सिंपल सा पॉइंट है. ऑर्डर ऑफ सर्किट क्या होता है? ऑर्डर ऑफ सर्किट मीन्स दैट द नंबर ऑफ एनर्जी स्टोरेज एलिमेंट प्रेजेंट इन अ सर्किट. If you have only one energy storage element like inductor or capacitor, that will be a first order circuit. For example, this is your first order circuit. For example, this is your first order circuit because we have only one energy storage element present here. है ना? If we have two energy storage element present here, like in this, I have both inductor and capacitor. I have both inductor and capacitor. Then it will become your particularly the second order circuit. So on, we can have any order circuit depending on how many energy storage element present in a circuit. Okay. For your course, you will only have first order and a second order circuit. Our more focus will be on first order. In upcoming classes, I will discuss second order also. Okay. Now, why the order is necessary? Order is necessary because if you have a first order circuit, the formula of time constant is fixed. The formula of time constant will be R multiplied by C in case of capacitive circuit. The formula of time constant will be L by R in case of inductive circuit. This point is important to understand. This point is very important to understand. Let me write down R total. So according to the first order circuit, you can use the formula directly. But this thing or this formula is not applicable for the second order circuit. Can anybody tell me how to find out time constant in second order circuit? In first order circuit, आप एकदम से निकाल सकते हो, कोई दिक्कत नहीं है. But what will happen for the second order circuit? How will you find out the time constant? Think about it. That's your homework. And let me tell you guys, in the last history of the gate examination, only 2 times a question has been asked for a time constant in case of a second order circuit in the last 30 years. So that topic is not important, but for your knowledge or for the interview perspective, you should know the answer. But a Laplace तो निकालेंगे, that's correct, by using a Laplace. But what condition we will use? I'm asking that, कि what condition we will use there? Okay, think about it. I will give the answer in the end of a class. Think about it, not homework नहीं है. Class के end में मैं आपको answer दूंगा इसका, ठीक है? So now, before going further, you should understand the you should understand here, what are the important time instant in case of transient? What are the important time instant in case of transient? So let me draw a timing diagram quickly. And after that, we will go to a concept directly. So I have a timing diagram. The origin here shows t equal to 0. The origin here shows t equal to 0. Now beta, what is the t equal to 0? Resonance. No beta, not resonance. What is the t equal to 0? T equal to 0 is the instant at which the disturbance occurs. Instant at which disturbance occur. Disturbance occur. So whenever I'm going to provide a disturbance like switching on, switching off, short circuit or anything else, that instant is known as a t equal to 0. After that, 2 instants are very important. One is t equal to 0 plus and one is t equal to 0 minus. Your whole transient analysis based on these 2 instant. T equal to 0 plus, t equal to 0 minus. Now, what is t equal to 0 plus? It is the momentary time just after switching. Or what is t equal to 0 minus? Momentary time just before switching. So in t equal to 0 minus, the circuit is not in a transient state, but in t equal to 0 plus, the circuit is in a transient state. Okay, understand this point. Now from here to here, till the transient dies, transient dies at settling time, I can say Ts. So from here to here, we have a transient state. After transient state, we have a steady state. You can say till t tends to infinity, or you can say till next disturbance occurred. Before transient state, also we have a steady state. So one point you need to understand here, that t equal to 0 minus is a part of a steady state, t equal to 0 plus is a part of a transient state. Understand? And t equal to infinite also the part of a steady state. Okay, so this timing diagram we should understand here. Now one more point, transient occur, I told you, transient occur because of these 2 things, sudden change and a storage element. So sudden change is in our hand. Okay, we can provide a short circuit, we can do the switching on and off. although the lightning, you see the lightning on a transmission line, there also the transient creates. So that is also a part of a transient analysis. So that is a thing that we can create or that can happen naturally. But the main point is here is the storage element, the behavior of a storage element at all of these time instant. How does inductor behave, capacitor behave at t equal to 0 minus 0 plus ts and infinite? That we need to understand here. So for that, you should remember this table. For that, you should remember this table. At t equal to 0 plus, at t equal to 0 plus means we are talking about in a transient state just after switching. So at t equal to 0 plus, what will happen? Resistor will remain as it is. Inductor will act like an open circuit. You can also represent like this. Inductor is act like an open circuit. Why this happen? Does anybody have any idea why this happen? That inductor act like an open circuit? Because beta, let me tell you, in inductor, current does not change suddenly. In inductor, current does not change suddenly. Current does not change suddenly. So if in the inductor before switching the current is 0, then after switching also the current will be 0. Okay. Now let me write down it separately. I can also write down separately here. You can just remember this also, that inductor is act like a current source. Inductor is act like a current source at t equal to 0 plus. Now magnitude of this current source is the inductor current at t equal to 0 plus, and in the inductor, since the sudden change of current is not happen, so IL0 plus is equal to IL0 minus. This you should understand. This you should remember. This you should remember. This point is very, very important. In inductor, the sudden change is not possible. That's why you can see IL0 plus and IL0 minus are very, very near to each other. So this is a sudden change. So for this, the current after switching is equal to current just before switching. And that's why inductor at t equal to 0 plus behave like a current source, having magnitude this. Okay. If I talk about for a capacitor, you should remember the property that voltage across capacitor does not change suddenly. Voltage across capacitor does not change suddenly, VC0 plus. So here VC0 plus is equal to VC0 minus. Now understand one point. What is VC0 minus? What is IL0 minus? They are actually the initial condition. If I say what is IL0 minus and VC0 minus, they are actually initial condition. Initial condition means before switching, what is the current and the voltage in the inductor and capacitor, that is given by this particular terms. So because of initial condition, let's suppose the inductor is not charged initially. So the current will be 0. For current to be 0, it will be an open circuit. That's why you can see this part. If I say about voltage, in case of voltage, if the capacitor voltage is 0 initially, then this magnitude of voltage source will be 0. It will act like a short circuit. So there will be a short circuit here. Okay. Otherwise, you will have some values. Understand till here? Tell me guys. समझ गए इस चीज को कि किस तरीके से t equal to 0 plus पे आपका इंडक्टर कैपेसिटर बिहेव करेगा? Because almost in every question you have to use this concept. Okay. If the initial condition is not given, the first step for any transient question is to find out the initial condition. Then after that you can go for the question further. Now if you talk about t equal to infinite, t equal to infinite, or I can say a steady state. Now understand this point. This steady state is also before t equal to 0. Means you can say t equal to infinite, and you can also say at t equal to 0 minus. You can also say at t equal to 0 minus, because just I told you steady state also occur at before t equal to 0. So at both the time instant, either infinite or 0 minus, or you can say the steady state, Kannadi has said absolutely correct. Resistance will behave like as it is. Inductor will behave like a short circuit. Inductor will behave like a short circuit. Capacitor will behave like a open circuit. Capacitor will behave like a open circuit. A very, very important point. No need to see here. No need to see here. Just remember one thing. At steady state, your inductor will be short, capacitor will be open. As it is. खत्म आपकी बात उसी पे. ठीक है? Understood this point? Now, how to solve the question of transient? How to solve the question of transient? Let me add one more page. Here, the question is how to solve the question of transients. Okay. So beta, I will give you a flow chart here. Follow that flow chart, and I give you guarantee कि 99% question will be solved by your that flow chart. Okay, उठा के आप देख लेना. If you have any question of transient, कोई भी question दिया हो, चाहे first order हो, second order हो, any question of transient. It may be first order, second order. No worries. Any question of transient, the first step is to find initial condition. The first step is to find initial condition. If the initial condition is already given, then no need to find it. If it is not given, you have to find initial condition. Now, initial condition means you have to find out inductor current at 0 minus and capacitor voltage at 0 minus. It means you have to draw your circuit at t equal to 0 minus. But RLC circuit is actually a second order circuit, Rajesh. So that I will take the day after tomorrow, the second order circuit. First, I will focus on first order circuit mode because your 80% question moves around the first order circuit. Okay. Day after tomorrow, I will take second order also. Okay. This is a 4 days class. So I will take every topic of transient. So find initial condition. Initial condition means you have to draw your circuit at t equal to 0 minus. And from there, you have to find out IL 0 minus and VC 0 minus. Now, after that, you have to see whether you have a first order circuit or a second order circuit. If you have a first order circuit, what you can do? If you have a first order circuit, then you should check the source. What is the source given? You should check the source. If you have a DC source, then use the shortcut formula. I hope everybody knows about shortcut formula. Yes or no? Comment section में बताओ मुझे shortcut formula पता है आप लोगों को? Use the shortcut formula. Let me write down here. Shortcut formula tells you voltage across any element, okay, any element is equal to V infinity minus V0 plus e raised to power minus t by tau. Okay. So use shortcut formula means that you can use this formula. In this formula, you have to find out voltage at infinite. You have to find out voltage at 0 plus and the time constant tau. These three things you need to find out, put in this formula, and you can find out voltage across any element. So if this is a DC source, for the current also, we have I infinity minus I0 plus e raised to power minus t by tau. And let me tell you guys, 75% question is aate. Your 75% question will come from this formula only. Okay, understood here? When we solve the question, you will understand the concept very well. Now, if you have any other source, for example, here we have a DC source, na? Any other source, matlab, we will have an exponential source, we can have a step signal, we can have a ramp signal, we can have a AC source. Okay. So if you have any other source, then what? Then you cannot use the shortcut formula. You have to use Laplace transform. You have to use the Laplace transform method, or you can use the partial differential method. Now, partial differential method become difficult if you have a complex circuit. If I provide you 2 or 3 branches in a circuit, then the partial differential method become difficult. So I will advise you go for the Laplace transform, because you already know Laplace transform, you already use the Laplace transform in signals in your control. So you're familiar with the Laplace transform method rather than partial differential method. Okay. Next, if we have a second order circuit, then again you can either use the Laplace or a partial differential method, but I will advise you to use the Laplace transform only. You have a Laplace transform method, or you can use the partial differential method. So kindly take a screenshot for this particular page. Okay, your every question is going to be solved using this. Your every question is going to be solved using this particular chart. हाँ, there will be a questions in which they are asking something else. वहां पे फिर हमें out of the box सोचना पड़ेगा. Otherwise, your 90%, 95% question will be solved using this particular chart only. Okay? Understand here? Any doubt? Any doubt, बच्चों? Okay, fine. Okay, so let's start. Now let's start the concept with the first circuit. We have a first order circuit here, as you can see on your board. First order circuit means that you will have, if you see here, we have a RC circuit. So we have a capacitor here, we have a capacitor here. So this is the first order circuit. What is the difference between these two circuits? What is the difference between these two circuits? बताओ मुझे. What is the difference between these two circuits? It is the source free circuit. It is the source free circuit. Or it is the forced circuit, you can say. Forced circuit. Now, what is the meaning of source free circuit? Source free circuit means that this capacitor, which is an energy storage element, this will be charged. This will provide the energy to the remaining network. Otherwise, if there is no source, capacitor is not charged, how will you think that energy will be supplied? It means here in a source free circuit, this capacitor is always initially charged. It is always initially charged. It will be initially charged always. Okay. Now, this is the forced circuit. Forced means you're applying a particular source here. Source can be DC, AC, exponential. You're applying a particular source here, and because of that, the current will start to flow. And the capacitor will start to charge or discharge. So here, capacitor may or may not be charged initially. May or may not be charged initially. May or may not be charged initially. Okay, understand this point? Understand this point? So these two particular circuits we are going to see one by one. So first we will have a source free RC circuit. We need to find out the capacitor voltage here. We need to find out a capacitor voltage here. So here, you can use the concept that I gave you in a chart earlier. Also, you can use the concept of partial differentiation. Also, you can use the concept of Laplace transform here. So I'm telling you this thing, that Laplace transform or partial differential is applicable for every network, But the concept of shortcut formula is only applicable for the first order circuit. Okay. So let's solve this question using the partial fraction method. Okay. After that, in upcoming questions, I'm going to use shortcut formula. Let's solve this question by partial fraction method. So suppose the particular current is flowing in this direction. This is the current I flowing in this circuit. So I can say minus V plus IR is equal to 0. Now, because it is a source free circuit, I need to assume that initially the voltage is V0. I need to assume that initially the voltage is V0, or it will given in a question. So applying the KVL, I can write down minus V plus IR equal to 0. From here, I can say V minus IR is equal to 0. Now, what is I? I is the current flows in this circuit through the capacitor. Now, we know this point that capacitor current is equal to C dV by dt. We know this point that capacitor current is equal to C dV by dt. Any doubt here? If capacitor current is C dV by dt, I can write down V minus C dV by dt R equal to 0. You know? Achha, do one thing. It will be V plus IR. We can write down this here. So what will happen here? So I can write down dV by dt plus 1 by CR multiplied by V equal to 0. This is the equation we got, differential equation we got. Now, how to find out the solution for differential equation? Remember, we find out the complementary function and partial integral method. So here you can say it is a homogeneous equation because it is equal to 0. So what are the roots here? Roots are d plus 1 by CR equal to 0. So roots here comes out to be minus 1 by CR. So if this is a roots, then voltage is equal to C e raised to power minus T by RC. So if you know how to solve the differential equation, then this method is easier for you because you learn the differential equation in case of a mathematics. I'm using a mathematics concept only here. Nothing I can use from the network analysis. It's a mathematical concept. Now this is a constant C. So I can put at t equal to 0, V is equal to V0. It means C e raised to power 0 is equal to V0. I can say C is equal to V0. So finally, what is the voltage across capacitor? It is V naught e raised to power minus t by tau. This is the voltage across capacitor. V naught e raised to power minus t by tau. Now you can see that equation is a discharging equation, right? That equation is a discharging equation. Why it is a discharging equation? Because if you increase the time, the voltages keep on decreasing. है ना? And also, because we are talking about source free RC circuit, capacitor is actually discharging. Capacitor is actually discharging. So since capacitor is discharging, that will be V equal to V naught e raised to power minus t by tau. Understood? Also, I can find out the current that is flowing here. The current is C dV by dt. The current is C dV by dt. With this concept, I can find out the current also. है ना? So C V naught d by dt e raised to power minus t by tau, or you can use the RC, RC. So I comes out to be C V naught minus by RC e raised to power minus t by RC. C से C cancel हो गया. I comes out to be minus V naught by R. Minus sign shows here that the actually direction of current will be reversed. Minus sign will be shows that actually डायरेक्शन ऑफ करंट विल बी रिवर्स्ड. एक्चुअली यहाँ पे मैंने डायरेक्शन रॉन्ग ले लिया. केवीएल इक्वेशन मैंने सही लिखी, यहाँ पे मैंने डायरेक्शन रॉन्ग ले लिया. So now according to this direction you will have a KVL equation, and because of that you can see current comes out to be minus V naught R e raised to power minus t by RC. Also beta, you can use the shortcut formula. Using a shortcut formula is so much easier here. How? Because we have a first order circuit, so I can say the voltage formula is equal to V infinity minus V naught plus e raised to power minus t by tau. Sorry, t by tau. है ना? ये हो जाएगा. Now here you can see what is V infinity. V infinity is going to be 0. आप पूछोगे सर ऐसा क्यों? V infinity 0 क्यों हो रहा है? सोचो बेटा, कैपेसिटर के अक्रॉस वोल्टेज निकाल रहे हो. If it goes to a steady state, capacitor will be completely discharged. If capacitor will be completely discharged, the voltage across it will be 0. That's why V infinity is 0. What is V0 plus? The initial voltage that we have assumed is V naught, and tau in RC circuit is equal to RC. So here, what will be the VT here? VT will be 0 minus V naught e raised to power minus t by RC. So it comes out to be V naught e raised to power minus t by RC. This is the voltage across the capacitor here. Simple. By using the concept easily, we have find out voltage across capacitor. कोई doubt यहाँ पे? जल्दी से बताओ. If you have any doubt here, you can ask. This is t by tau. Okay. If you have any doubt, you can ask. Okay, fine. Current भी find कर लें. Current को हमने बस differentiate किया, कुछ नहीं. For the current, we have differentiate here. So this is actually the response curve. Vt comes out to be V naught e raised to power minus t by RC. You can say at t equal to 0, it is 100% charge here. After that, voltages keep on decreasing. Now here you can see what is tau. Tau in case of discharging is the time at which 36.8% value will be decreased, or you can say the 37% also. After that, you can see around 4 tau. You can see around 4 tau, the voltage becomes 0, which means the transient is going to be die here. Transient is going to be end here. Since transient is going to be end here, the voltage across the capacitor is 0. Okay. So transient time actually lies in this interval, depending on condition ki how much error you require. Okay. Understood this point? Yes or no? Understood this point? Jaldi se batao comment section mein. Tell me in the comment section, have you understand this point? And bachcho, like the session so that we will see you are actually watching the session, right? So understand this point? Batao comment section. I'm waiting for you. Okay, next one. Now let's try to solve this question. It's actually a 1 mark question. Let's try. It's a 2 mark question. So try to solve this question quickly. We have given the switch in the circuit in figure has been closed for a long time. And it is opened at t equal to 0. Find Vt for t equal to 0. So here we need to find out voltage across capacitor at t greater than 0. Calculate the initial energy. चलो ये हम बाद में देखेंगे, पहले वहां देखते हैं. Find Vt for t greater than 0. Now first of all, observe the circuit. The circuit you look like is a first order circuit. So the first step is to find out the initial condition. Since initial condition is not given here, I need to find out the initial condition. When we find out the initial condition, we only find out two things: inductor current and capacitor voltage. Here capacitor is given, so we will find out only and only capacitor voltage. So what I will do, I will draw the circuit at t equal to 0 minus. At t equal to 0 minus, which is a steady state, capacitor will be open circuited. यहाँ पर क्या होगा? Capacitor will be open circuit. So if I redraw the circuit, the switch is closed. देखो t equal to 0 पे switch open हुआ है, तो 0 minus पे switch has been closed. So the circuit will be like this. 3 ohm, 9 ohm, 1 ohm. The circuit will be like this, and I need to find out the capacitor voltage at 0 minus. Okay, Anand says 15 volt. Well done. So कैसे find करेंगे? Simple. I can apply the voltage division rule. There is no current flows here, so whatever be the voltage across 9 ohm, that will be the VC0 minus. So 20 multiplied by 9 divide by 9 plus 3. तो कितना हो गया? 9 by 12. तो 20 multiplied by 9 divide by 12. So we can solve it. 3 से क्या? 4, 3, 5, 4, 3, 15. Correct. We have 15 volt. So VC0 minus comes out to be 15 volt. Well done. So if VC0 minus is 15 volt, I can say that VC0 plus is equal to VC0 minus is also equal to 15 volt. Okay. Why? Because this is the condition for a capacitor, that voltage across it does not change instantaneously. Now after t equal to 0, this side of circuit has been removed. We will have this circuit only. If we have this circuit only, I need to find out the time constant. Now time constant is equal to total resistance divided by C. Now understand here how to find out the total resistance. For the total resistance, you have to observe from the energy storage element side. You have to observe from here. If you observe from here, 1 ohm and 9 ohm are in series. So we have 1 plus 9 equal to 10 ohm. So tau comes out to be 10 multiplied by 20 into 10 raised to power minus 3. So it comes out to be 0.1 seconds. It comes out to be 0.1 seconds, right? If I'm not 0.2 seconds, sorry. It comes out to be 0.2 seconds. 0.2 second, correct? Now from here, I know what is the shortcut formula, that Vt is equal to V infinity minus V0 plus e raised to power minus t by tau. This is the formula. This is the shortcut formula here, beta, that we need to use. Now here you can see what is V infinity. The capacitor voltage at t tends to infinity. Now capacitor is in discharging mode. Since you have removed the switch, the capacitor is in discharging mode. So beta V infinity will be 0. The capacitor will be completely discharged. Now what is the V0 plus? Already calculated, 15 volt. E raised to power minus t by 0.2. So Anand has given a right answer, which is e raised to power minus t, 15 volt. Absolutely correct. I hope और बच्चों का भी आंसर आया होगा. Okay, simple question है. This one is a very simple question. तो I hope आप लोगों का आंसर आ गया होगा. अगर नहीं आया तो I hope you have understand this concept very well. Okay, we have to find out the initial energy stored in the capacitor. Now what is the formula of energy stored in capacitor? Half CV square. So energy stored in capacitor is equal to half CV square. They are asking initial energy. So I need to use the initial voltage. Which is a 15 volt. तो कितना आ गया? 225 आ गया ये. तो 10 0 minus 2 हो गया ये. हाँ, 2.25 जूल. 2.25 जूल. बेटा एनर्जी निकालनी है. What is used for the power? We need to find out energy, so it will be joules. Okay, understood? Good. Next one. Now before going further, let me tell you guys that you can download our BYJU'S exam prep app where we are actually practice questions a lot on a daily basis. Here we also have a facility to provide you leaderboard where you can compete with other students, other aspirants, and you can see where you can stand and you can study well. So daily the classes are going on very well here. Also, bacho, I have also started my analog batch here, in which in yesterday's class I discussed about the important topics for both electrical and EC that you should revise before the examination. In today's class, I'm going to discuss previous year question for both branch from the year 16 and 17, correct, at 4:30 p.m. So this series is actually based on questions only. So we will revise the concept through questions. So I will highly advise you to follow this series. It's going to be on app and it is a free classes. Also, bacho, from next week, I'm starting a signal and system previous year question also on the app. Okay, so don't forget to follow it. Download our app, follow me there, and you can get notification of my classes. Also, you can join my Telegram channel. Now next. Now we have a RC circuit with a source. RC circuit with a source. Okay, so here we need to find out a capacitor voltage again. Now I'm going to use the shortcut formula only. If you want to use the partial differential method, you can watch my previous classes. You can just search transient analysis by Ishan Mudgal. There you can see the partial differential method. Okay, but now we are only going to use the shortcut formula. So here you can see, beta, I need to find out a capacitor voltage. Source is DC. If the source is not DC, then we have to use the Laplace method or partial method. So here you can see, let's suppose kar lete hain pe, suppose initial voltage in a capacitor. Initial voltage in capacitor is V0. This I'm supposing. It means capacitor voltage at 0 plus is equal to V0. Okay. Next, if I say what is the capacitor voltage at t tends to infinity, so use your mind. Once the switch is closed, if I talk about the steady state, the whole voltage is going to be stored in a capacitor. The whole voltage is stored in a capacitor. So that will be Vs. Actually, voltage is not stored, the charge is stored. But just for a sake of convenience, I'm saying voltage. But actually, charge is stored by the capacitor. So that charge divided by capacitance give you the voltage. है ना? याद है ना ये CV equal to Q. What is the time constant here? Again, when you see the time constant, you have to see from the capacitor side and the voltage source will be short circuit. So if you see from a capacitor side, we have RC. Now use the formula directly. Vt is equal to V infinite. V infinite is Vs. Vt is equal to V infinite minus V infinite minus initial voltage V0 e raised to power minus t by tau. E raised to power minus t by tau. This is the formula of the capacitor voltage in this type of a circuit, which is a RC circuit with a source, also known as the forced circuit. Understand this concept? We can also find out the current here, IT. We can also find out a current here, IT is equal to C dV by dt. है? We can also find out the resistor voltage here. Resistor voltage here is equal to whatever with the current IT multiplied by R. What will be the current IT multiplied by R? Simple Ohm's law. IT multiplied by R. है ना? So once we have a capacitor voltage, here we can find out easily. Explain again, sir. Amrinder, see beta very carefully. I told you about the shortcut formula. I told you about shortcut formula that Vt is equal to. Wait a sec. I told you about shortcut formula earlier that Vt is equal to V infinity minus V0 plus e raised to power minus t by tau. So what we have done here, we have find out the first of all what is V0 plus. So this I have already assumed that initially capacitor is charged with the voltage V0. So that will be the initial voltage Vc0 plus. Okay, either it is given in a circuit, or if it is not given, you can take it as a 0. Or if the circuit is given, you can find out the initial voltage from there also. For example, in the last question, here the initial voltage was not given, but we have find out using an analysis what is the initial voltage. Okay. Then after the switch is closed, if I talk about the steady state, the switch remain closed. So at steady state, whole voltage will come across the capacitor because the capacitor will be open circuit. So the entire voltage will come across the capacitor. So that's why capacitor has been charged to a supply voltage, which is Vf. time constant is simple. It is a RC circuit. Time constant will be RC. Now I have put all of these formula, all of these particular values in this formula, and we got this answer. बताओ क्या doubt है इसके अंदर अमरिंदर? We got this voltage. From there we find out a current. We can find out current by using a simple concept, C dV by dt, and then resistor voltage also. Okay. So this is actually your particularly response curve. This is the response curve here. Here you can see beta, the equation is in actually a charging equation. The equation is charging equation. This is a charging equation. Why it is a charging equation? Because the capacitor is charging to a higher voltage Vs at t tends to infinity. So initially it has some voltage V0. After that it is charging and reached to the Vs. कोई doubt यहाँ तक? कोई doubt यहाँ तक? बताओ. Do you have any doubt till here? Do you have any doubt till here? Okay, fine, good. Now let's do one question over it. Let's do one question over it. Very good question. Very, very good question. Let's do one question over it. The question is, the switch in figure has been in a position A for a longer time. At t equal to 0, the switch moves to position B. Means this is a disturbance occurred in a circuit. Determine Vt for t greater than 0. Determine Vt for t greater than 0. We need to find out a capacitor voltage here. So again, shortcut formula. Just remember the shortcut formula because we have a DC source here. So according to shortcut formula, what will be the Vt? Vt is equal to V infinite minus V0 plus e raised to power minus t by tau. This is the shortcut formula. Now first of all, find out the initial condition. Initial condition occur when the switch is at position A, because initially the switch is at position A, then it will be thrown at position B. So for initial condition we have to draw the circuit. For initial condition we have to draw the circuit at t equal to 0 minus. We have to draw the circuit at t equal to 0 minus. Now remember, at t equal to 0 minus, capacitor will be open. At t equal to 0 minus, the capacitor will be open, and there is no need to include this side of a circuit because the switch is at position A. So I need to find out capacitor voltage at 0 minus. I need to find out capacitor voltage at 0 minus. तो बताओ कितना होगा? 24. So can I say VC0 minus? VC0 minus is 24 multiplied by 5 divided by 5 plus 3. है ना, 15 हो गया, 8 volt. So VC0 minus comes out to be 8 volt. If VC0 minus is 8 volt, then according to the property of capacitor, VC0 plus equal to VC0 minus, it is also 8 volt. According to the property of capacitor, the voltage does not change suddenly. So VC0 plus equal to VC0 minus is equal to 8 volt. So we have find out the initial voltage done. We have find out the initial voltage done. Now let's see how to find out the voltage at infinity. So once the switch will switch to position B, है ना? The switch is at position B. This side of circuit is not going to be important here. Now for t greater than 0, this circuit is important. For time greater than 0, this circuit is important. Now see very carefully. Here we have a capacitor. Here we have a voltage source. So this voltage source will charge the capacitor to 30 volt. Yes or no? This voltage source will charge the capacitor to 30 volt. Right? So I can say, what is the V infinity? V infinity is nothing but the 30 volt. Understand this here. At steady state, the capacitor will charge equal to the supply voltage. Capacitor will charge equal to the supply voltage if it is connected in series with the source. So here capacitor is connected in series with the source, so it will charge to a supply voltage. Okay. What you are saying? It will be 15 volt. 15 volt होगा. एक बार चेक कर लेता हूँ मैं. 24 into 5 divided by 15. 15 volt कैसे है यार? ये 24 volt है, ये 5 किलो ओम है, 3 किलो ओम है ना? हमने इसमें लगा दिया वोल्टेज डिवीजन रूल. So 24 into 5 divided by 8. अच्छा, my 8. हाँ, 15 volt आएगा. correct. Stay correct. I have done a calculation mistake here, but you are correct. 5 just 15. 15 volt. Correct. 15 volt होगा, है ना? Correct. So it is also 15 volt. It is also 15 volt. It is also 15 volt. Correct. Now what is the time constant tau? Time constant tau, you have to see the circuit after switching. R and C. Always remember, when you find out a time constant, that time constant is for the circuit after switching. So after switching, this circuit remains. So time constant will be RC. So 4 into 10 is to power 3, 0.5 into 10 is to power minus 3. कितना बचा ये? 2 बचा? I guess 2 ही बचेगा. ठीक है? Now put all the values here. So V infinity is 30 minus 30 minus 15 e raised to power minus t by 2. So simply कितना आ गया? 30 minus 15 e raised to power minus t by 2. Absolutely correct. And this is your 2-mark question. This is your 2-mark question. हाँ, Ananta was correct. हाँ, correct. वो मेरी calculation mistake हो गई थी. He is correct. So VT comes out to be 30 minus 15 e raised to power minus t by 2. Okay. Now, further, they are asking calculate its value at 1 second and 4 seconds. So what do you need to do? Just put the time 1 second and 2 second and 4 second here. You will find out the answer. Okay. कोई doubt यहाँ तक किसी को? Any doubt till here? ठीक है. Now, before ending a session, this we will do tomorrow. Before ending a session, let me give you one homework question. Okay, try this homework question. I want answer in a comment section. I want answers in a comment section. Try this question. It's going to be a very good. You can take a screenshot here and give the answer in a comment section. Why this question is important? Because you have a dependent source here. So try करना. अगर नहीं आएगा, I will tell you in the next class. Okay, now before. Sorry. Okay, so before ending a session, let me give you one information here before ending a session. Okay, we have started the crash course, Gate 2024 crash course for all of you guys. So you can join this crash course for EC and EE. We are providing a live classes. And the recorded lecture, study material, mock test, and practice quizzes. You can practice a lot with us on this particular topic, for a gate examination. And once you will enroll it, you are providing a guidance also, and complete syllabus will be covered here. Okay. Steady state 30 volt कैसे आया सर? Previous question में. अच्छा बता देता हूँ इनको. फिर 30 volt कैसे आया था? Simply देखो, we have a capacitor here, and because the switch is connected, we have a resistor here, and here we have some voltage 30 volt. Okay. This happens. This is R, this is C. Okay. Now let's draw the circuit. Now let's draw. हाँ, thanks to remind me this. मैं अभी आपको बता रहा हूँ वो चीज. Now let's see very carefully. Let's draw the circuit at t tends to infinity. Now t tends to infinity पे बताओ capacitor कैसे behave करेगा? Rajesh, how will capacitor behave? Capacitor will be open circuit at t tends to infinity. Capacitor will be open circuit plus minus 30 volt. Now here you can see, because it is open circuit, the whole voltage will come across. So can you say the VC infinity is 30 volt? Can you say the VC infinity is 30 volt? Yes or no? Yes or no? है ना? So इससे अच्छा आप मतलब ये ड्रॉ करने से अच्छा याद कर लो, अगर कैपेसिटर वोल्टेज सोर्स के सीरीज में होता है तो स्टडी स्टेट में उसके अक्रॉस जो वोल्टेज होता है दैट विल बी द सोर्स वोल्टेज. ओके, अदरवाइज क्या होगा? मान लो इस तरीके से हो. लेट्स सपोज मैं एक और आपको डायग्राम बनाता हूं. लेट्स सपोज वी हैव अ सर्किट लाइक दिस. लेट्स सपोज वी हैव अ सर्किट लाइक दिस, प्लस माइनस 30 वोल्ट. दिस इज 10 kilo ohm. This is 10 kilo ohm. Okay, let's suppose this is a circuit. Here again you can say what is the voltage across capacitor? Now voltage across capacitor will be voltage across 10 kilo ohm at steady state. Why? Because if you go for t tends to infinity, capacitor will be open. And whatever be the voltage across the resistor, that will be the voltage across capacitor. So by using a voltage division rule, you can find out. ओके, सिंपल केवीएल केसीएल का कॉन्सेप्ट है, उस कॉन्सेप्ट को अच्छे से स्ट्रॉन्ग करो. नाउ व्हाट वाज आई एम गोइंग टू से इन द एंड ऑफ अ क्लास. हाँ, याद आया मुझे. आई टोल्ड यू टाइम कांस्टेंट इन केस ऑफ सेकंड ऑर्डर सर्किट. टाइम कांस्टेंट इन केस ऑफ सेकंड ऑर्डर सर्किट. ऑल्दो फॉर एग्जाम पॉइंट ऑफ व्यू इट इज नॉट इंपॉर्टेंट बिकॉज इन लास्ट 30 years ओनली 2 times हैव बीन आस्क्ड क्वेश्चन ओवर इट. सो फर्स्ट ऑर्डर सर्किट के लिए आपको पता है टाइम कांस्टेंट क्या होता है, आरसी और एल बाय आर. इसमें क्या होगा, you have to find out the characteristic equation. you have to find out the characteristic equation. After finding out the characteristic equation, you need to find out the poles. You need to find out the poles. You know what is the poles? Poles are the value of poles are the value of S where the characteristic equation is 0. I hope you know what is the poles. Characteristic equation जहां पर 0 होती है वो S के points, that are the poles. We will find out the poles. Then time constant is equal to 1 divided by magnitude of dominant pole. 1 divided by magnitude of a dominant pole. 1 divided by magnitude of a dominant pole. Dominant pole का मतलब क्या है? The pole which is nearest to the origin. For example, आपने बहुत सारे poles निकाल लिए. एक pole ये रहा, एक यहाँ पर, एक यहाँ पे, एक यहाँ पे, इस तरीके से है. तो the pole P1, it is nearest to the origin. This pole P1 is the nearest to the origin. That will be the dominant pole. So reciprocal of a dominant pole magnitude will give you the time constant. This is for the second order circuit or any higher order circuit. Okay. If you talk about the first order circuit, you know the formula, that is RC and L by R. Okay. Understood? Yes or no? Understood? Yes or no? So guys, we will end our session here. And don't forget to attend my class at 4:30 p.m. today in app. We are going to discuss previous year question of 16 and 17 from analog electronics. So see you there. Bye bye. Take care. And we will see the YouTube class tomorrow at the same time, 3 p.m.